There, let me find a better backdrop.
Hello, everybody. How you doing? Daryl and I are just talking about a couple things here, and Daryl's with us. And we will be checking out the early winter sky tonight, and it looks like it's going to be pretty. It's catch as catch can tonight, as they say, because we do have some clouds. We do have some clouds moving up from the south. So we want to be careful about that, but we'll check it out anyway. So hi guys, welcome. It's so nice to see all of you. And let's go now and see who's here. Okay, we have Renee Cruz, we have Daisy and Zoe. Hi guys, how are you? Carol Carl is here. Tara's here. Daryl's here too. Daryl, are you here?
I should be.
I believe so. And
actually, you have my picture now if you care to scare everybody with it.
Okay, let me grab that too. Marianne is here. Hello, Marianne. Carol Carl. Cheryl, Texas. Welcome. I'm glad you came in. And we've got lots of people that are just joining us too. Gina Leone is here too. Hi, Gina. Welcome to SkyTour LiveStream. And we'll get off the observatory shot in just a moment. I just want to make sure I catch everybody so far. I love making a habit of saying hello to everybody, because if you guys go through the effort of coming here, then I should actually go through the effort of saying hello to you. That's my feeling. All right. So, where'd you send that picture, Daryl?
I just opened it in Skype. Do I have to send it to you?
Yeah, because I don't see it. So we're on a call, and you have to put it in the chat for the call.
Okay, give me just a second.
No problem. No problem. So guys, how's it going out there? I mean, I'm thinking that maybe you guys are probably itching for a stream, as I am. It's a beautiful night so far. Probably gonna change, but for now, we'll just go for it. We'll do it. Okay. So I would like to just welcome you again. All of you. Bob Harless is here. Hi, Bob. And so now what I'll do is I'll bring us over to our actual startup view that we like to call the remote view. This is our remote cam view, and this is our observatory down here. You can see the telescope in the observatory right here in the lower right-hand corner. And we spend a lot of time doing kind of like introductions to this whole approach, right? So like on the left side here, this is the telescope control system. Down here is me. Hello. Okay. Daryl does not want to be seen. So
I'm trying.
He's trying. Yeah. And then up in the upper right here, we have the camera control. And then down below on the right, as I said, that's actually down there, is the view into the telescope. And these are resizable, so there's something going on there. We want to look at it and go, hey, what's going on in there? We can check it out. So that's what this is all about. That's what it's for. So that's affectionately called the dome cam, and this is the ops cams for, the ops control, actually the control room, so to speak. Because I used to do this from in the dome, and now I do it from inside, because I managed to remote the dome, and it's a very important thing to do, especially in the winter. Yes, Daryl, sorry, you were saying something.
I'm sorry, can you share your screen again with me?
Yeah, what happened?
I'm not sure how to get my video to you. I clicked on the share screen on it.
Okay.
Folks, if this works, you're going to get a rare look at the real me.
Oh yeah, you're right. I didn't share the screen.
Well, you did once, but it went away.
Okay, that's because you probably tried to share something as well.
Okay, what do I need to do to get my video to you, if not share screen?
Turn on your video camera in Skype, maybe?
I'm sorry?
Turn on your video camera in Skype?
It is.
Okay. Alright.
I turned off the share screen.
Okay. That's why the share went away. It's shared again, so you can see it now.
Yes.
Okay, so we'll have to we'll have to probably figure this out kind of off stream, just to
Okay, try it some other time then.
yeah, because I can't. I'm sure it's easy, but I'm a little under the gun with the potential clouds coming in.
Go ahead. Very good. Carry on, please.
No worries. Well, anyway.
Sorry, folks. We'll have to wait some other time.
Well, I do have images I can put up of you with your telescope, the binocular telescope. Yep. So.
That's all right.
Okay. So anyway, we are sitting here. Daryl decided to join us, and I think Amanda, I don't think she got back to me on whether she could join us tonight. So, yeah, she is not. So, no Amanda tonight, but that's okay. We had her last night on SkyTour LiveStream. SkyTour Radio. All things SkyTour, get confused. So, anyway, I'm feeling that tonight is a good night. This star that we're looking at right here, by the way, this is actually Aldebaran. Aldebaran is located in Taurus the Bull, and this is where we're looking. This is Aldebaran right here, right? And we're looking right here, and Aldebaran is a star that's actually just about 66 or so light years away. Maybe plus or minus. The numbers do change from time to time as we get better data. And the Hyades, which are these cluster of stars behind it, are actually much further away, more than almost 3 times as far away as Aldebaran. Aldebaran's a lot closer. That's why it's so bright. Okay, so literally we're looking at stars that are, minimally twice as far away. And it varies because it's 3-dimensional. Space is 3D, remember? So it's kind of cool.
Aldebaran is the eye of the bull.
That's right. And in this particular program called Stellarium, which is free, by the way, if you guys want to play with it at some point, we can show you the eye of the bull. There it is. That's the bull.
Yeah, the V shape of the Hyades is the head of the bull, and Aldebaran is his big red glaring eye looking at you.
Mm-hmm. Like they usually do. They're glaring at you. Yeah. So, yeah, so... Go ahead.
The tips of his horns are over to the left, and one of them, Alnath, is a star that Taurus shares with the constellation Auriga.
That's Alnath right there.
Mm-hmm.
Okay. It's also known as Beta Tauri, second brightest star in the constellation of Taurus. You'll notice the Alpha, Beta, Gamma, Delta, designations. Those are the Greek alphabet. And in the early days, we measured the brightness of the stars, and we gave the brightest star Alpha, and the faintest star would be further on down in the Greek alphabet. So consequently, we would actually end up memorizing the entire Greek alphabet over time. And so I know it, Daryl probably knows it, but we won't bore you with it, but that is something that helps us along, and we figure things out this way. We also have this object right here, which we're going to look at tonight. This is the Crab Nebula. This is a supernova remnant. Now, right now, the Crab Nebula is pretty faint. You cannot see it with your eyes. In fact, you need a reasonably good-sized telescope to see it at all. And this particular object was so bright that you could see it during the day back when it happened, and that was in 1054 AD. And it was the Chinese that discovered it because it was a new daytime star. And it was this star that was this object here. So there was a potentially bright star right here where the Crab Nebula was, or is now. Okay? And so it's literally well over 2,000, well, actually farther than that, 6,000 light years or so. It's 6,500, I think, from memory. And I think that, the stellar core, the remnant left over from the supernova, is a pulsar that's spinning very, very rapidly. And I think that speed was, 33 times per second?
Something like that.
Yeah. And in astronomy, we say hertz. cycles per second. So it's 33 hertz, or 33 cycles per second, and that's a star about the size of, say, Manhattan, maybe a little bigger, and it's spinning as a sphere 33 times per second.
It's a neutron star, isn't it?
Yeah, it's a pulsar, so it's a neutron star with these hot spots on it, and these hot spots are high radiation zones that it gives off, and that radiation is like a lighthouse beacon. And at the distance that this thing is from us, it's no harm to us. Okay, but we do see the pulses, and if you slow it down, if you take an image of or you watch the Crab Nebula with a radio telescope and break it down, you'll actually see, if they convert it to sound, you'll see but you'll hear that 33 times per second. So it really just goes but if you slow it down, you'll hear okay, and that's those lighthouse beacons swinging around and hitting us and then going by and doing it again. Now, over time, pulsars do change their rotation rate. I mean, people say, well, there's nothing stopping them, so why would they ever slow down? Because there is stuff stopping them, and there's a lot of forces at play on the surface of these neutron stars that become pulsars. So there is drag of a sort that occurs on a neutron star and in a pulsar, so they do end up changing their rate, and they do spin down over time. But that time could be the lifetime of the universe, because once it's spinning, it's hard to stop them, with that much mass, because it is a lot of mass concentrated into something that small.
Yep.
Yeah, it's beautiful.
And they spin so fast because, first, as neutron stars go, I guess 30 times a second isn't all that fast, but it's that ballerina pirouetting effect again, that as the neutron star collapses, it's just like not the ballerina, the ice skater.
The ice skater, yeah. Well, ballerinas do
the
it
ice
too.
skater pulling in her arms, and that increases her rotational rate, and same thing's happening right there.
Yeah, and in physics we call that the conservation of angular momentum. But
right.
When you do that, and you do pull your arms in, you spin faster, as Daryl said, and if the star is smaller, it's going to spin faster, and the more massive it is, then potentially the higher the spin rate. Really cool stuff, and that's not the record. 33 times per second is kind of slow. When you consider the fastest is over 700 times per second. 700 times per second. These pulsars are things you don't want to mess with. Really, Hey Genghis, hey Rock, hey Ronald, hey Doll Eyes here. Good to see you guys. All right, let's go look at some things. I don't want to start off by saying I got to go move the dome, but I was checking out the Pleiades a little while ago, and I might have, depending on how fast the clouds get in, I might want to try something else. Okay, I might want to actually show you how I take the raw images and turn them into the final beauties that they are. Okay, and just a little hint. We'll come over here now and show you this here that you're about to see. This is the Lagoon Nebula, re-imaged with our telescope and using special noise reduction techniques that I've been talking to you about. This is what it looks like now. I mean, that's beautiful. Look at all that dark nebula. This is the kind of thing that astronomers dream of, is to catch the beauty like this. And this whole nebula, incidentally, is a summertime nebula. You see this hourglass shape right here? That's a star right next to it. That star right next to it is an O-type star, one of the hottest in the universe. And it's responsible for doing a lot of the lighting up of this nebula that we see here. All right? Believe it or not. So their radiation reaches far and wide. But there's other stars that are helping this nebula glow. So we're going to go look and see if we can find some of these nebulae tonight, some other nebulae that are here in our approaching the winter sky. And I think that we'll be able to. I think we'll be able to do that. So, that said, I know, Renee, you want extraterrestrial aliens, ghosts, and UFOs. Trust me. Me too. Me too. And who knows? Maybe ghosts are just incursions into our three-dimensional space by interdimensional aliens moving through that border, that doorway. You know, they may not be ghosts at all. It might be parallel universes bleeding through into our own. Believe it or not, there's actually physics behind that. Not mine. Other people working at Cornell and Princeton, I believe, papers in the Astrophysical Journal talking about this. It is just incredible. The universe is opening up, folks. And if you listened to SkyTour Radio last night, you heard us talk about the crash and collapse of the iconic Arecibo Radio Observatory in Puerto Rico. We lost the most high-resolution radio telescope on Earth when that happened. It wasn't the biggest, but it was the highest resolution. It's an odd thing anyone who knows about telescopes might say, how can that be? It has to do with the construction and the way the dish was built. So, that said, I think that's probably just, it's never good news, but it is something that we will be able to recover from.
Something I've wondered about that, the Chinese basically copied and scaled up Arecibo when they built their fast observatory.
Correct.
Which we also talked about last night.
Yeah.
And knowing the Chinese tendency to use shoddy engineering and construction, I wonder if maybe they're having second thoughts now.
Well, maybe, but the Arecibo telescope's in a very different location climate-wise. And that's something that has to be considered too. The maintenance on Arecibo was very high because of the rainforest climate at times down there, very high humidity at times. So that was a problem, right? So we have to consider that maybe we're looking at something that might survive longer in the dry and arid location in China. Just like we know the Atacama array, the submillimeter array in the Atacama Desert, it's 5,000 meters above sea level. So we know that that's going to survive the test of time, without a doubt. Because it's a dry location. It's very dry. So I think that's a good thing. Okay, I'm not sure if we have it, but I'm going to give it a shot here. I'm waiting. What we do is, this is our live view in the middle here, okay? And as I said, camera, observatory, telescope control, and me control. Trust me, I need to be controlled. And so now when the telescope finally gets on to an object, we actually have to then wait about 11 seconds precisely for the telescope to acquire a guide star, because it's self-guiding. Okay, and so now that it's done that, I can go over and start the exposure. So I turned on the camera to go now, and it's running off and doing its thing. And then over here, this is the last shot of the Pleiades I took. I took a number of them, okay, and I was doing so because I was thinking that maybe I'd like to show you how I stack images and how that's done, so you can see how the details. This is a raw image, okay, right off the telescope. So the question becomes, well, how do you turn that into a masterpiece? Well, you turn it into a masterpiece. Okay, looks like. Oh, don't tell me there's a cloud. Oh, that would really spoil my day. That pink glow. That looks like a cloud. It was totally clear when I came in. All right. May I go check the sky, Daryl?
Well, sure. Is your sky cam still up, or have you taken it apart?
I packed it to send out to Arizona.
Ah.
So that's the only reason I'm not looking at it. We would have known ahead of time. Okay. After all this, let me be right back. I'll leave you on this right here. I'll be right back.
Okay. So, hello everybody. It's another beautiful day in Colorado today. Sunny, not a cloud in the sky. Temperatures got up in the 60s. We've had a really remarkable run of nice days lately. It is getting cold at night, though. And Jupiter and Saturn are continuing to come together over in the southwest after sunset, and need to start looking pretty early in the evening because they're going away earlier now. I could easily cover them both with a single finger width tonight. Absolutely knockout skies here. What's the verdict?
I'm totally clouded out.
Uh,
I have no idea how this happens. It was totally clear. Totally, utterly clear. I came in, I started the stream, 10, 12 minutes elapsed. I was going to go take a picture of Hind's Variable Nebula, not Hubble's Variable Nebula, Hind's Variable Nebula with all of you. And it's cloudy. It's like, how in the world does that even happen? I was looking so forward to doing this with you guys. Alright, well, you know what? Instead of being a total loss, here's what I'm going to do. I'm going to give you a little glimpse into what we do when we do image processing. If you want to watch. If not, okay. So anyway, the first thing we do is we have to stack our images, okay? So we take many images of the same thing, right? So for instance, and I'll do something other than the lagoon. And I won't take you through every little detail, but I'll show you kind of roughly what we do. So this is the tool I use. People use Deep Sky Stacker. I use Sequator. I use both sometimes. They're tools which take a photo and align them with each other and then stack them on top of each other. So they take all these photos, align them, and then stack them. Okay, so for instance, if we want to get star images, we go out and I have plenty of directories we can try. So let's try. Actually, this will be a good one. Okay, we'll do. I think, is it this one? All right, just a minute. I have an idea. Okay. So these are images of the Eagle Nebula, which is a summertime shot. Okay. Now, this is what the raw image looks like. Let me see if I can show you. There you are. There's the raw image, okay? This is right off the camera, okay? Now, if you zoom in on this, you're going to see all this noise. You see that noise? You know, that looks terrible. Typically, that should just be red or maybe a little bit dark. You know, and that noise is a problem. We have to get rid of the noise. But that's after, okay? So what we do is we take all the raw images that I took, these guys right here, and we load them up, all right? And then once we do that, we go and get images that are going to help us process out the noise. And these are... I keep these sort of in a repository outside of all of this. And I'm going to go through all this to show you exactly what's going on. All right, these are probably about here. I'll say 62nd to 40,000. Okay, probably these guys. So, don't worry, I'm going to show you what I'm doing. All right. I hated in school when professors would actually say all these things and then say, okay, I'll show you in a minute what's going on, and then they never do. That bothered me. Okay, so let's go set an output file. All right, and the output file is going to be very simple. I'll leave it in this main directory here, and we're going to call it Eagle for STLS. Okay, we'll make it a TIFF file because that's the least amount of garbage associated with it. Okay, so here's what happened. I got all my star images. You see them up here on the left. All right, they were all similar exposures. Okay, and this is one of the raws. This is what the raw images look like. They're not very pretty. Okay, and then the noise images are images to help us with all this modeling in here, this noise. And so that's what I brought in before. The way you take those is you put the cover on the telescope and you take photos of blackness. And what you get is the noise on the chip, on the sensor. And that is a lot of what we're seeing here. Okay? So I include the noise images, and it's going to align. It's going to align all these images up here. Okay, so all these images right here are going to get aligned with each other and stacked one on top of the other. And then the noise images are going to be taken, and the noise images, there's 13 of them that I included. And these guys are going to be literally subtracted from all these images. But after one master is made of those noise images, a master that has all the noise from all 13 of these files that I've included for the noise. And then we're going to subtract that from the master stack. All right, and that's going to give us a final result. Now, there's other things you can do. You can do what are called bias files and all that stuff, but I'm not doing that. All right. I'm also not worrying about the vignetting, which, if you notice, is a little darker here on the corners. Okay, that has to do with how far back from the telescope the actual camera is, and it's looking through a barrel, going into a filter wheel, and then into the telescope. So all that induces a slight shadow from those tubes. Okay, and that we're going to get rid of later on, but we don't even have to. I usually just crop it out, as you'll see. So now here, I just said a few things that I do typically, and suffice it to say that I'm doing very little here. All right, and okay, it says the noise reduction has failed. I think that's because maybe they're different size. No big deal, because I can still fix it. Let's pretend the noise worked, because I can get rid of it anyway. All right, so here's the final one. Now compare that to the other image that I showed you a little bit ago. Okay, and this has been saved, by the way, and it's out in our directory that we saw. I'll show you. Okay. Oh, thank you. That's good. No, that's good. Yeah. Okay. Yeah. Wonderful. Okay. So now what we'll do is let's go open that file that we just stacked. All right. And it's going to be literally in our drive right here. Right here. This is where everything is. I actually stuck it here. Eagle for stls.tiff. This is the actual file, all right, that we just stacked. Okay, and there it is. Now, if we zoom in on this, okay, you'll see that the noise is a little better than what we saw earlier. All right, and by that, I will show you exactly what we saw earlier. I'll bring one of those in. So we're going to go back to that directory and go back to that directory and grab one of the eagle shots, and I'll show you what that looks like. So this is a raw shot. So that's a raw shot, and this is here we go. Okay, it's going to do that, right, because it wants to do that. That's a shot taken with a different filter. It's my mistake. I took that with the with a different filter. I got the wrong directory shot. Sorry. So pretend that didn't happen, and let's now go back and do this again. Okay, so we'll go back now, and we're going to look at it was Eagle with Eagle. It wasn't this one. I think it was one that had I think I had something else in here. Hold on. Here it is. This is the one. Yeah. Okay, so this in this directory right here. Okay, this is These are our raws. So now I'm going to open up our raws and I'll show you what we're looking at. Okay, so here it comes. That's the stacked one right on the screen now. And it's doing it again. Okay. Now let's do this. Okay. Okay. See that? See how noisy and nasty that is? All right. Now take a look at the difference. Okay. This is the same relative area. Okay. Oops, sorry. All right. Same relative area. Do you see the difference? I think it's pretty clear, right, that this does not look at all like that. So stacking does that. It gets rid of a lot of that noise, you see? So already we're in better shape. Okay. Now there's things we need to do because even though this looks pretty good right now, all right, we have to still get rid of the noise, because if we look at this and zoom in, you can see that there's this speckled noise in here. Well, there's no speckling in space. We have to get rid of that, but not compromise this data. All right. So here's what we're going to do. We're going to come in and we're going to, well, first of all, let me show you over here on the right. Okay. You see here, this, I don't know if you can read this. It says MLD Astronomy Actions. I wrote some little mini processing in here to help us do things, that you do a lot. Okay. Things like, see the blue color cast in the background? Okay, I don't want that anymore. Obviously, we don't want that. That's not real. But if I select it and I say run, boom. Okay, now it's a realistic color. All right, because I actually did the comparison to the actual background, and I was able to set that to a neutral color and thus bring out the actual color of the nebula with one click, rather than come through and do about 18 different steps to get to that. All right, so there's our color has been removed. The color cast has been removed. So now we have a good shot. Now the other thing we can do is in Photoshop, we can look at just the red parts of the sky, the nebula. See these faint things up here? There's got to be something in there, right? So if we actually look at our, we look at our curves, all right? When we look at the curves here, I think that we can see that there are some really good things we can change. These are curves. I don't expect you to understand this, but just watch what happens when I pull this one on the far left. I move it over. Okay, see what's happening? Okay, and little by little, okay, this is what you might get to see in a moderate-sized telescope with your eye. Okay, the bigger the telescope, the more you'll see, and you can see about to there. But to get into this kind of detail, with all this additional nebulous detail out here, you need a really big telescope. And if you don't have that, you can take a long exposure photograph like this was. Okay, these were 1-minute shots. All right, and so now that we can see that, one of the things that's important here is to be able to look at. Let me just do this. Some.
You lost your sound, Mark.
You can't hear me? You hear me? Hello? You hear me, Daryl, right? Daryl doesn't hear me, but it's going out to all of you. That's strange. Okay, 1 second, guys. Just got to do a little. Daryl, you're muted for one thing. Let me. Okay, just 1 second. I'm telling Daryl that my sound is going out. So you can see my. You can actually see my volume bar going out over. Can you hear me, Daryl? Okay. Okay, so not sure what's going on there. All right. Well, anyway, we'll keep going. Hopefully, he'll make it back. Not sure what happened. Anyway, so coming back to this again, if you look at this again, when we look at the curves that we've been playing with, we can actually take those curves. If I say image adjustment and go to curves. Okay, these curves, which again I don't expect you to know, but see the red, green, and blue? Well, all the colors are made from various blends of red, green, and blue. So if we look at the red part, okay, watch what happens when I raise up this part here. This is mostly the red in here, right? You can see it there. That's where the red is. If I raise this up, look at the screen. See, we're getting more and more red. So now that's way too much, of course, and it really puts too much in here, but it gives you an idea of how much you've actually got there. You know, so it does show us some possibilities, all right? And so what I do is I just bump that up just a little bit, okay? And then I come over and I look at the other levels that we were playing with, and I do come over here and I try to darken the background a little bit without compromising the data. See, so then we have that. Okay, now the most important thing happens. We have to get rid of this noise. Okay, so see how that's pretty nasty looking. It doesn't look really, really good right now. So if I come over and I say, all right, now we're going to get rid of this noise. We're going to use what's called a filter. And I usually put it through a couple of these. This filter here is one that I use a lot. And what it does is it takes the noise and helps us get rid of it. Okay, so on the right side, you can see what happens after the noise filter is applied. On the left, you can see before. And you can see now, that's nasty. That's better. That's looking better, right? And so if we come down and we bring us down into the heart of the pillars of creation, which is actually what this is that we took. Okay, you move over, and that's the harsh reality of the unadjusted raw file. But then you come back, and it starts to look a lot better, doesn't it? And what I typically do is I just make a few adjustments based on my background and having done this quite a lot. And I sharpen, and not sharpen, but I reduce some of the noise a little more, but without loss of detail. Because if you actually get rid of most of that noise, okay, then look at how soft the nebula gets. Look, see how soft it looks? It doesn't look very good. So if I actually drop this down and go to, say, like maybe 40%, okay, now we still have structure, and we actually get rid of some of that noise, a lot of it, but not a terrible amount. So we can actually go up a little bit. Let's go to, say, 56, 61%, 62% is good. All right, and now as we move, see, that looks good. And that's one of the noise reduction systems. All right, and now when it comes back, you see now it's actually looking, well, it's looking better, right? But we're not done yet, because there's another thing to do. I'm actually going to darken us a little bit more. Okay, and just a bit. Okay. All right. Interesting. If you guys are having trouble hearing me, let me know, will you? Because Daryl's saying that he still hears the music. Yeah, Martian, this stacking reduces the noise as well, but it's not the answer. The full answer. You actually have to make sure that you use noise reduction systems. I actually have one that I use here, okay, and it's a denoise artificial intelligence, and which I really like. It's by Topaz Labs. And if you notice, when this starts to come in, let me bring it up a little bit. Okay. All right. Now, again, like before, the split screen on the left shows you what it looks like before the noise reduction, and then on the right, look at that. See, we're getting a huge difference, right? And it doesn't really affect the detail in the nebula that much. Now, there's a lot of settings within these noise reduction algorithms, and this is one that I'm using now. And you can do sharpening and noise reduction and everything, but that can also induce some artifacts. So I tend not to use too much of it. You can always use too much of these good things. Okay. All right. So this is kind of cool. All right. And it reduces some of the noise, but it also gets induces what's called color noise. All right. So I've just reduced the color noise as well, and it's looking okay. Okay, Tara hears me and the music. Good. I don't know what Daryl. I'm wondering if it's actually your side. Try your jack, pull it out, put it in, and see if that's it, because that might be a problem. Good thing it didn't happen yesterday in the show. Okay, so these noise reduction is actually one of the things that is really critically important to doing this kind of work. So that's why I use it a lot. Okay, so now we've done this, and so we've reduced the noise. Yeah, Daryl's not talking Martian as far as I can tell. If he is, I can't hear him, and nobody can hear you, Daryl, if you're actually talking. So, I still have you in Skype, so whatever you do something if you can to, hold on. Can you hear me, Daryl? Daryl? Okay. Yeah, you should be able to hear me now, Daryl. Make sure you're not on mute. Okay. Yeah, so I think I know what happened, Daryl. The key combination that I use to actually go into a particular dialog box here is also the key combination that mutes me to you in Skype. But it doesn't mute me in OBS. So people still heard me, but unfortunately in the Skype conversation you didn't. So if you're still out there, you can actually respond. So anyway, so here you see, this is an example now of just a few stacked images and the result that we get. It really actually makes a huge difference. And then what we can do is we can do a whole bunch of things. All right. And if I do some more adjustments with the curves, I don't hear you, Daryl. You must be on mute, because I don't hear you. And it doesn't say you're on mute. Daryl's saying he hears me now, but he doesn't hear him. I don't hear him. Well, tell you what, Daryl. Let's hang up and I'll call you right back, and people will get to hear that. All right. So if you can hear me, you hang up and I'll call you right back. No, he just hung up, so he can hear me. So here we go, and I will call Daryl back, and you get to hear the music. All right,
hello.
All right, now you can hear me.
Yeah.
And I can hear you.
I don't see your screen now. Can you share again?
Yes, I can. Sorry. Here we go. So now we're sharing with the music. Okay. So what we did.
Okay, much better.
Yeah. So what we did was we, as you saw but didn't hear, the people out there heard, because it's weird. Dalai is saying he can only hear the music, but that's not now, of course, right?
Right. I hear you. I hear the music.
Yeah, okay. All right, well, I don't believe that, Skype is a separate piece. The microphone is still sending out data to OBS, so everybody in OBS should have heard me. But anyway, so here is an example then of what we can do with this product. This is Photoshop, of course, but oh, that's Daryl, by the way. There's a little picture right up there you see of him. Okay, I didn't realize I was on that side. I have several monitors, and that was on the left side. So basically, what we're trying to do here is to illustrate for you how this can work, and how we get these masterful, beautiful pieces out of what seems to be just noise. So that's oops, that's that guy. So that is right there. That is exactly the kind of thing that you can expect when you take the time to work on these guys. And let me just show you one more time. This is an example of the raw. Okay, this is actually a JPEG, which I don't typically use, actually. So that's a little rougher. So we get rid of this JPEG, and I will bring in the actual raw file of which one of these is a stack. Stacked within here. Okay, so here's one. All right. So here comes the. It's probably going to bring it into. Yeah, there we go. All right, let's just say open. Okay, so there it is. That's the raw file, and it has all this noise in it. Look at spurious red dots and everything. That's called color noise, and it has to be taken out. And hey, Marco, and hey, Q. So by doing that, we actually ended up coming back through to creating something that was just a little more. Well, it looked like this, and let's just bring us to that same location here. All right, just about. And when you go look at it, okay, it's kind of hard to really see that it's the same place in a nebula. Okay, but to see it for sure, you back out, and there it is. Okay, we're actually looking right about here, right? And once you actually do all the work, look at what you get. Okay, it really, really does make a huge difference. You can easily see. So I'm sort of hooked on this, and we actually take pictures now at very high sensitivities, like this picture was taken, and then we can get rid of the noise and make it look like that in the end. So it's really a good thing to do.
I've probably asked you this before, but do you actually see an eagle in that picture?
You have said that, and not in this one yet, but maybe here. I would look at this as the eye and the beak and the bottom of the beak and the mouth's open. Is that what they see as an eagle? Or do they see an eagle with its outstretched wings? Or is this the extent of the eagle? I don't know.
If you focus on the pillars of creation part there, more toward the middle, the lobe on the left that is kind of going up and farther over and down to the left.
That one?
The dark lobe, farther down.
Oh, right here.
Farther down. No.
Oh, this one.
The one on the left.
Oh, this one.
That one. That's the wing. Now,
Oh.
his head, the way I've always seen it, his head is the middle lobe.
This one?
And that tip right there is the tip of his beak. Then the third lobe is to the lower right. That's like his foot.
Oh.
That's how I always saw the eagle.
See, but this looks like a thicker wing. This looks like a membranous wing, like a bat. So this could be the Bat Nebula. I don't know. I really don't know why they call it the eagle. I've never been able to. I've never been able to figure out why this was called the eagle. Some of these nebulae, it makes sense. You can figure it out, right? But I'll tell you, I don't know. I don't know why. Just don't.
Well.
Yeah, I know. But while we're here, no, that's good. That's a good thing. It's a very important thing to figure out why these look that way. Let me see if this gives us something else too. I think you guys have been with us when we looked at this guy. Okay, and
Doll Eye says he sees a duck. I see a duck decoy when I look at what
really?
is it, M21 Omega Nebula?
Really? Yeah.
I've told you. Yeah.
Yeah, of course. You're right. That looks that way. This is the double cluster, and if we actually just rotate this, this is the actual orientation of it. All right, and this is a nice deep photo, and of course, this is a one shot. So basically, what I do with these is I just come in and I take care of taking out my. I use my color cast removal macro I developed and do that, and then really quickly, all I have to do now is go and get rid of the noise that you see in between here, and this noise is actually real easy to deal with in this particular guy. All right, and here it goes, and it's going to be gone here in a second. And then look at that. Talk about difference, huh? And so I actually tend to go a little less on these things. I try to do as little processing as I need, So this is the double cluster process, and this is just one shot because it doesn't need more than one. You don't get a lot from stacking this one. So when it comes in, you'll see it now. But that said, every one of these images takes some time, to actually tease out all the information and all the data in it, and this one's taken a while, I guess, because I left it kind of big. And the other thing I can do, by the way, and this is something that Isabella Melamed found out, she wanted some of our prints, so I sent her some of the prints, and she turned them into these beautiful framed portraits that she hangs over her computer table over in Sofia, Bulgaria. I love it. And okay, so what happened is that we can take now all these images, and if they're not high enough resolution, we can make them now high enough resolution so that you can actually make them wallpaper. You can make them 14-foot wallpaper. Okay, and I've done that with a few of the prints, and you can actually print them out, and there's actually sites to do it, where you can actually take what I create and as a large print, and print it out any size you want. So it's really beautiful, and it's amazing. Oh, and Isabella is here. You have a question? Go ahead. Hey, David. David Schmidt's here. So there is double cluster, all right, processed. Let me go in and grab one other in this same directory that I think I may have shown all of you. This may not be the right one. This might have been a poor night. Yeah, this wasn't a very good night for the elephant's trunk. But I know that I did have a beautiful night with the elephant's trunk and the bubble. So let's first of all do the elephant's trunk, show you that. This was one night when I just chose to come out and just check it out. So here is the elephant's trunk. Now, look at that. You can almost see it in 3D, against the background stars. Isn't that beautiful? This is a dark nebula. And if you look at it up close, you can see that a lot of the noise has been removed from this. There's very little noise left in this image, when in the raw files, it looked mostly noisy. You couldn't even see any of the dark, So
I remember your early elephant trunk image efforts. They don't hold a candle to this one.
Yeah, this removing the noise with the artificial intelligence algorithms that Topaz has just made a huge difference. I mean, look at this. It's almost like an eye, okay? And inside this little eye here, you actually have stars that are inside that have cleared this area out with their stellar winds. I mean, what a beautiful location. I'd love to be there, Let's see. Isabella had a question. The images received in the telescope was black and white by channel H alpha. Oh, that's right. Okay. Okay, Isabella wants to understand basically how narrowband filters acquire images. That's a really good question, Isabella. And one of the things that we do is we acquire images in SkyTour LiveStream using a filter that gives us hydrogen alpha, which is the glowing red of the hydrogen that you see here. Okay. O3, which is doubly ionized oxygen, which is the bluish color that we often see in nebulas like the Dumbbell Nebula, right? Is that bluish green color is that characteristic color of doubly ionized oxygen. And then sulfur 2, which is another component that actually brings us some of the red, all right, and makes it more rich. And those three filters give us a full picture of the nebula. Everything that's going on in the nebula comes from those three particular elements. Okay, comes from hydrogen, comes from oxygen, comes from sulfur. Now there's a few other things in there too, but if you then take an exposure in the hydrogen alpha, the red for the red nebula that you see here, okay, and then you take an exposure for the O3, you won't get much here. But then you take an exposure for the S2, okay, the sulfur 2, okay, that's going to present you with more details than getting together like we have here, because you can adjust how long you want to take an image in the sulfur filter. You can adjust how long you want the hydrogen alpha filter to go, and the O3 you might just cut short. Here we're doing all the same length of time, and it's the differences in time which get us the differences in the nebulae. In the interest of time, I don't do narrowband filters, with you separately. I do them together, right? I'm using what's called actually a quad band filter, right? We're getting all of those band passes in one photo. Now, it doesn't give us a lot of control in the end over how much of the red in particular we want to show versus the sulfur or the O3, but in most cases you don't really care about that, especially for the public outreach stuff we're doing. Okay, so what happens, Isabella, is you take each of those sets of images separately. Okay, so you take, say, 25 hydrogen alpha images of this nebula, okay, and then you take, say, 25 O3 images and 25 sulfur 2 images, and those could all be different lengths of time. The O3s might be short, okay, and then you stack them all separately, and then you bring those three separate images, those three separate stacked images, the hydrogen alpha, the oxygen 3, the sulfur 2, you bring those into Photoshop and you combine them here into one finished shot, and you can adjust how much sulfur 2 versus the hydrogen alpha you want, and vice versa, and etc. And that's the ultimate in control of your exposure. But we are not doing that here, because can you imagine sitting through 80 exposures of one object? I wouldn't do that to you. And maybe it's me too. Maybe I don't have the patience to want to do that, but I think that it's okay. It's a beautiful way to take images. It's a classic, and it's actually the preferred method. But we also do this, and I think you wouldn't argue that what we do is not so bad. Okay. Now, I saw one question about why is this dark. This is dark not because it's dark gas. There's no such thing. All gas is transparent, relatively speaking. The gas that has suspended particles in it, however, will be darker. Okay, think in terms of bromide gas. It actually looks brown. You can see it. Okay, that's because that's actually a particle nature of that gas. There's gas, but then there's particles in there, the bromine, and of course it's deadly. You don't inhale it. And so when you look at something like this with this dark nebula, we're actually looking at a lot of diatomic hydrogen, which has no opacity, has no inability to see through it, and it's mostly dust grains, these very, very small, several micron or micron sized dust grains. They were all forged in the hearts of the red giant stars before those particular stars went supernova, all right? And then when some of these red giants sloughed off their outer layers as they got older, well, then we saw that some of these dark filamentary structures and some of these dark dust clouds that appeared were the result of these shells being dispersed into the interstellar medium. So that's what happens here. That's the kind of thing we're seeing here. And this is not the result of, say, a supernova per se. This is the result of just the accumulation of billions of years of stars going boom and stars puffing off their outer layers as they got older and began to reach the end of their lives. All right. And because it's a heavily ionized region, I mean, there's a lot of stars in here that are sending off ultraviolet radiation that are causing the hydrogen gas to glow like this, right? Because there's a lot of those, this is not a good place to live. We don't want a planet over there. No. Okay, we want a planet somewhere else. We want a planet, I don't know, way the heck out here somewhere and much farther away or much closer, away from the ionizing regions, because those will sterilize a planet. You know, Mars' surface is sterile because of the ultraviolet radiation from the sun. See? So it doesn't take much. So anyway, so that's how the three filters work, Isabella, and that's how come these are dark, because it's actually dust grains. Okay, but in Orion, which I was going to show you tonight if it didn't cloud up, the Great Nebula in Orion, that has dust lanes in it too, but it also is a lot of this dust, but it's also infiltrated with a lot of, well, diatomic molecules of hydrogen, and that's two hydrogen atoms that are connected by bonded together. Okay, and this is part of something called the Orion Molecular Cloud Complex, the OMCC. Okay, and the OMCC is something that is fosters a lot of star birth, a lot of stars are being born in the Orion Nebula as we speak, and all throughout that dark region where there's this molecular clouds, it fosters the ability to clump. And when things clump, they tend to, in space where there's no other gravity other than where the clump is, things tend to clump more and clump more and clump more because it's a mass, and now it's attracting other things. And that's how planets are formed. That's how stars are born. And our universe has done this billions of times, trillions, actually beyond our math, because look at this one shot. If I told you to count all the stars in this image, it might take you the better part of 2 weeks to actually do it. And you say, well, no, I can see those stars. Yeah, you can, but now count them. And it's going to take you about 2 weeks to get through all this. That's my estimate. Okay, because where you see one star, there might be two. It might be a double star, So it might take you longer, actually, because, you're only seeing part of this image. It kind of goes up and it kind of goes down a little bit. So, yeah. So that's this. Okay, this is the elephant's trunk. And this is actually, I took this in part of the sky here where it's actually not the darkest. Okay, it heads towards some of the light pollution that we have here. But the idea is to figure out a way to get around that light pollution, and that's what this is. That's what all these techniques are that we've been telling you about. So let's see. Now, off to Isabella Melamed's favorite object. This is one she has on her wall that we did for her. Okay, it is this one. This is the Bubble Nebula, and this is a gorgeous image. I added diffraction spikes just because people think stars have spikes on them like that, so I put those in, but I do have others that don't have it. Hey, Sandy boy. So this guy here, all right, this, you can see this bubble. Now, this is an image where for the first time we were actually able to record the entire bubble, because we had not been able to get the whole bubble before. We only got the arch up here. And this image, we actually caught the whole bubble. All right. Now, what's interesting about the bubble is that there's a very, very hot star in here that may go supernova at some point called a Wolf-Rayet star. They're very, very hot. And they are literally, they're so powerful that they blow off their outer layers. And those outer layers end up making this snowplow effect into the interstellar medium. Here you can see along this line, you can see this little line right here. That's an area where the snowplow effect right here. Okay, the snowplow effect here. This is where the snowplow effect of this radiation was pushing out into the interstellar medium, but there's very little to impede it. You know, so it stays nice and spherical in the shape that it had when it probably left the star. Okay, however, come over here, and now you got something very different over here. You've got this extremely complex area here where the stuff is bunched up, come to a halt. It's brighter because it's getting hotter in here, so we're getting other kinds of elementary atomic reactions going on in there, and it's getting bunched up over here. And so this is one of those areas where it's not the same on both sides. It's okay right here, okay, up here, because that's where the bubble is, right? But over here, it's actually not the same because the interstellar medium has a different density up there. And so when it hits there, it's going and slowing down and getting made to slow down. And as it slows down, it's of course getting hotter as it collides with other things. Really, really interesting stuff. But this bubble is something that, I don't know, this is probably the most complete image of the bubble we've ever taken, actually. And thanks to the ability that you're talking about before, Daryl, these images look so much different from the first images we used to take in SkyTour LiveStream.
They do. The difference is night and day.
Yeah, it is. And that's not even an astronomy joke.
It never even crossed my mind. No pun intended.
No, but it's good. Yeah, so you see, that's kind of cool. So, so reducing noise, getting rid of that noise is extremely important. As you can see, we've got lots and lots of things that we've gone to see out here, and I'm going to work on more of these at some point as well, because I want to make sure that I do get these processed properly. Some of them don't work out. Okay, like here's a stacked image of the region of the Cone Nebula. All right, now you can't really see it, but it is there. Okay, it's right there. But you notice that the stars are not quite round. There was a little tracking error on this particular set of stack images, so we don't tend to use those. We kind of let those just go. We're not we'll say, hey, not now. We'll come back to it at some point. And now here's the thing. Every one of these images that we've taken here, all these images in Arizona, they're going to be probably, I'd say conservatively, 15 times better. So that is going to be incredible, you know. And I'm really excited about that. I really am. I think you guys are too. You know. So let's see. Maybe we have another one that I can show you that I have here. Yeah, this is that can't be found. I know that. Okay. One of the ones that I think really illustrates this dusty nature of the universe is it this one? I've taken these things so many times, you know. Let's go see. Let's go see, Captain. All right, so let's take a look. Yeah, that's not the one. Then it's part of the North American Nebula. And the North American Nebula is one that really... okay, that one only had a few. Were you going to say something, Daryl?
No.
Okay. All right, maybe it's this one. That might be the one. You can see how many images get taken in order to do this. Okay, this is going to be the one. So this is one of those denoised images of the North American Nebula. Look at this. This is just crazy. And let me just get my head out of the way here. Look at that. You can see in this image, you can see all of this dark nebula. Okay, right here. All this dark nebula. This is overlaying the bright stuff behind it. Okay? It's not the bright stuff overlaying dark of space. This is a dark cloud of dust. Right? You can see it. Right? And then you got this. You can almost see this in 3 dimensions, can't you? Right? It's really, really beautiful. And, you know, these particular objects are just, well, I guess, again, stellar nurseries, breeding grounds for stars. But you look at this and you realize, look, all the noise has been taken out. The noise has been taken out. This was a very noisy image, especially where it was dark. Okay? But we managed to get rid of it, you know? And just so that for the record, and Martian, you're alluding to this now, I think. This particular set of imagery and all the imagery I actually have in duplicates on multiple SSDs, which are solid state drives. And for those that don't use solid state drives, you know the camera cards that are SD cards? Well, imagine those bigger with a lot more capacity. That's what I have. And I use them as the hard drive, the main drive on the computer. I also use them for what we call RAID storage. Okay, in fact, I just bought a RAID with 2 SSDs because data is gold. And just imagine if this picture got lost, you know? And you can say, oh, well, you just do another one. Yeah, you can. But, you know, the night was beautiful. This night was gorgeous. Look at the detail in this. And this is something, I mean, I stared at this picture for like this. I was like, wow. I can't believe that picture was taken here in, you know, some light polluted sky. I mean, yes, we can see Milky Way overhead, but it's just unbelievable how well you can process away the noise and the light pollution, you know. I also have in Photoshop here, I have something here that it's called where is this? Structure definer. And this guy will allow me to actually brush over some of these objects and have their fine detail brought out more. You know, it's something I had to write for this to get that, because otherwise some of the detail gets lost when you start removing noise. You know, and because sometimes the noise gets confused for data, and we don't want that. So I bring it back with that process. Yeah, it kind of negates the denoising. But that's beautiful right there, you know. But you don't need me to tell you that. I mean, you look at that. Some people look at that and say, oh, it just looks like clouds. Yeah, it does. And I'll sit there and stare at them all day, you know. And this guy, Daryl, you were with us for this one. I'll show you. Oh, I don't believe we stacked this one. We did this with white light. But this, if you remember this was Measure 66 supernova. And
oh, yeah.
I believe this was the supernova, right?
Yes.
Okay. Yeah, this was a supernova. Now, in terms of color, this object is a lot bluer than these other stars. And it kind of, I know it doesn't look it, but this has a cast that's blue that you can see. I don't know if you can tell that's got a bluer cast to it, you know, but it does. And that's something that points out to us that this is a very hot, very bright object.
That image looks pretty black and white to me. Are you seeing the same thing I am?
Yes, that's actually, it's the white light shot. If you notice, the star over here is slightly orange.
Oh, okay.
Yeah. Now, what I haven't done, for instance, is I did not stack these images. Maybe I did. I'm not sure. Let me go check and see if I did. Because that's a raw, I believe. But let me check out. No, I should have. Did I just not stack them? Huh. How about that? Maybe I did. Let me look down here further. Okay, well, I must have meant to, but didn't. Oh, I got an idea. Let's stack these. All right, so we're going to go into SkyTour, and we're going to remove all of our photo images, and we're going to change the output file to Measure 66 Supernova. Okay, and that, and then we're going to get the images. So we come out here, and we should see down the list here, where's Measure 66? It was here somewhere. I'm looking. We'll find it. I think it was farther back. Oh, M61. Was it M61? It wasn't it wasn't M66, it was M61.
I remember the supernova.
Yeah, my mistake. Okay. Oh, this is an earlier one. That wasn't actually the one I was just in. I did this another night. Oh, this must be it right here. Okay, sorry. Here we go. M61. That ain't it either. Interesting. I mean, I did have this, so let me go look. 614. No, it is M66. Well, I don't know why. We must have looked at two supernovas, Daryl. Okay. All right, so we got to go back to 614. There it is right there. Okay, M61 and the TIFF files. Sounds like a show about, like, I don't know, something crazy. The TIFF files. All right, so we just take all these and we're going to say open. And we got those. And well, we'll leave the noise files on there, but it might be different. Let's just see if it can do it. Leave all the settings. All we have to do is change the one setting there. Oh, okay. We did the noise reduction too. Oh, there we go. So we got our stacked M66, which I had not done before. I think that's pretty cool. All right, so now we go, and if we come back here, and we go, was it this guy? So in here, we're going to have our stacked M66 somewhere. Or did I put it in here? Oh, come on. Where'd it go? All right, I know where it is. We have to just come over here and get it. All right, so this is not the stacked one. That beauty has to go. And let's go look. We'll open you up. M66. And oh, I know where it went. Sorry. My output file, it's in the M61 directory. It shouldn't be there. My mistake. Hang on, I'll fix it. Okay, here we go. So now we're going to do it right. Okay, so this will be the M66 Supernova. Okay. And now let's do it again. It only takes a couple seconds. Boom, done. All right. And now if we just minimize this, we can go in and let's work on this now. So first things first, we're going to go out and in just to refresh the directory. And then it's probably down the bottom. There it is. There is this is M66, the TIFF file. Okay, first things first. Let's adjust some levels. Let's get the black to be more black. Okay, this is good because if you look at this now, you can see very clearly how this is a much bluer object than this star. See that? And now what we have to do is we can do a couple things. What we're going to do is this. We're going to go image adjust, and we're going to get these curves again. And I'm going to play with the curves a little bit to see if we can pull out any more data here.
When you talk about the curves, those are the histograms, correct?
For each of the colors, yes. But I'm looking at them as a total right now.
Okay.
I can go separately, though. This is the red curve, okay? And, of course, you look at the green curve, and it's going to be a little bit different placed. And then the blue curve is going to be slightly differently placed, okay? And if we come in here, we can click with our there's the eyedropper tool here. And wherever you see, if you look over here, you can actually see a square appearing and dancing around. That shows you where the blue is. If we go into the galaxy, check that out. Now the blue's way out here. In other words, the signal of the galaxy, that is the part of the galaxy that's the blue arms where all the new stars are being made, that data is very, very low relative to the noise of the blue in the sky. So what we can do here is we can come in here and we can actually put a couple of points in here that'll hold it there, and then we can actually raise up the area over here. And now if you notice, the disk of the galaxy alone is a little bluer. You see that? That's sort of a basic tenet of the image processing. So I just did a little more blue. You'll notice that the center is a little yellow and the outside is more blue, just like it is. Okay, so that's interesting how that works. And we also have some other considerations. Now, again, this is the supernova right here, and that's what we took the picture of. But we have all this noise, so let's go get rid of the noise. All right, let's go right to the noise reduction that I use from this particular set of tools, the Nick collection. All right, and you'll notice that that's a huge difference. Before, after. Before and after. The only problem is that the before and the after are too good. We have to try and bring back some of the actual color that we're missing. All right, so I have to be very careful here. So what I'm going to do is I'm going to just do a very little bit of the contrast noise, which is, contrasty. You can see it, the speckles. All right, and so that's reasonably good. So now I say, okay, now you watch the noise go away here in a second. Boom, a lot of that noise just went away, and the galaxy's starting to look a little more like a galaxy. Okay, now what we'll do is I'm going to take us into this other intelligent noise removal, and we'll do that. Okay, because I want to try and get some of this noise removed that needs to really go away. All right, so let's enlarge this. Okay, so let's bring it up here. Okay, and now there is after and then before. Well, it's too much of both, so I'm gonna try and reduce a little bit, see what I get. So what I'm really demonstrating here is using tools to remove noise, which are really effective at removing the noise, and that's something that has been a plague of astronomers for many, many years. Okay, all right, so that's the before and after, as you can see. And we're gonna come back on that a little bit. Go ahead.
I'm sorry, did you capture other galaxies in that image? You got one to the upper left and
I
a
do.
couple to the upper right out of the field of view now.
Yeah, I did.
Cool.
Yeah, we did that night. The field of view was spectacular. Okay, so now I gotta bring back just a little bit of the original again. Yeah, so that's... If we do too much, then you get artifacts created by the noise removal, and we don't want that. But if we just drop it like to this, then it should pretty much be the same as before. So it's the same, and ever slight increase, and we start to get an actual change that's very visible. Okay. Let me try sharpening madly and see what we get. Let's just try that. That'll be fun. We'll just try that. So now you can see basically that we're just trying to process the images digitally, and so that's what we get. And now it's still not perfect yet, and we're going to actually reduce the sky brightness background a lot more. Okay. There we go. And now you get to see this structure definer in use. Okay. I'm going to put this in now. Okay. And this shows us the structure that we want to define better. All right. And we're going to be fine. We just come in here. And now what we're going to do is come up to about here. Now watch. I'll reduce the size of this brush. I'm going to come in here. See, this is a spiral arm. Watch. I don't know if you can see that. See how the spiral arms are being increasingly defined? And you got to be careful not to go over stars, because you don't want to define stars more, you know. So now you say, well, that's pretty interesting. How's that look? And look at that. See, not so bad. Now, one of the things that we had here, which I don't really know if you can see, you can almost see a red cast over here. That red cast is that the dome was in the way just a little bit on this image. And we're just going to live with that. But here's the overall shot there, Olin. I don't know. Whoops, sorry. I don't know if you can see. You can see this other galaxy over here. Where is it? Right there. There's a galaxy right there.
Yes, you got one to the upper right too.
Yeah, and this is not it. That's actually there's one here.
Yes.
This is an artifact that I have since removed from the telescope, and I think that's one too.
Yes.
So this is a number of galaxies here. So as you can see, you know, this kind of processing can go a long way to really making sure that you get the best out of your images, you know. So what I'm going to do is I'm going to save this as a Photoshop document. I actually bought tools made just for astronomy within, you know, that they don't have Photoshop. But then I realized, but wait, I subscribe to Photoshop each month. I pay $10 a month and get this tool, the latest and greatest. Why wouldn't I do that? So what I did is I invested the time in learning how to use Photoshop. And now I feel as if it's a far better, much better way to go, you know. So anyway, that is some of what we're doing, you know. And what I'll do next is, you know, not tonight, but what I'm going to do next is I'm going to take and stack the Pleiades shots and show you how this nebula here comes out of the murk. You know.
I'm looking at the windy satellite map for your area, Mark. It looks like you may have a hole opening up in the clouds.
Let's go see. We can check real quick. Well, part of the reason that I wait is to see if, in fact, we can. So let's just take a 20-second shot at 51,000. It was totally cloudy when I went out earlier. No precipitation coming. That's why I didn't rush out and close the dome. But let's find out if we've got something here. We're still on Heinz Variable Nebula, by the way. Okay, let's find out. No. Was a good thought, Daryl. We got beautiful clouds.
Oh, well.
But
it looks like it's opening up just south of you.
Yeah, and south is coming to us, so I guess we could sort of hang out for a little bit and see what we get. You know?
We might check back later.
Yeah.
I'd like to answer David Schmidt, if I may.
Sure.
David, the date of the conjunction itself is on December 21st. Now, you being on the other side of the international date line, I guess that's going to be sometime on the 20th for you. The other date I mentioned was on December 16th, the 15th in your case, though the moon moves so fast, relatively speaking, this may not be as good a view for you if you see it at all. On December 16th, 5 days before the solstice and the conjunction of the two big planets, they're going to be joined by a young crescent moon. It's going to be just below and maybe slightly to the right of Jupiter and Saturn. And it'll be a young crescent. I bet if you have a view at all, you'll be able to see the Earth shine on the dark part of the moon, and it will render the whole view very three-dimensional. And it should look beautiful, naked eye at least, and I bet it'll be even better with binoculars. You probably won't be able to quite fit it in the field of view of a telescope yet, though. Not all three at once.
Donald Kunzer asked a question that relates to yesterday's SkyTour radio that we did, Daryl, about, although I don't know if you listened yesterday, Donald, asking about Jupiter and Saturn and their alignment later on in conjunction. And he wants to know if we're going to be doing a show on Jupiter and Saturn.
Yes, I see that.
Maybe so. I can set up a camera outside the dome and aim it up. It's sort of like Bill Skywatcher does. And kind of zoom in on that. And I can even put a camera piggyback on the telescope too, and let the telescope follow the planets all night long. And we can just zoom right in on it, really close with a telephoto.
Do you have a view to the southwest?
Oh yes.
Yeah.
Oh yeah.
Okay.
The only direction I don't have is the side that we don't really care about, and that's the west. From about 30 degrees up down to the horizon, the house is blocking that view. But I look at it as, if I haven't seen them all season long and I'm waiting now until they're in the west, my fault. Because they rise in the west and they set they rise in the east and they set in the west. So if they're setting in the west, it means I missed it all season? How could that be? Right? So.
Yeah, and everybody, if you saw what David Schmidt said, 15th and the 20th, that is for him because he is in Thailand. He's on the other side of the international date line. If you're in North America, we're talking the 16th and the 21st.
Oh, Daryl, who are you kidding? He's on the moon, for crying out loud.
Oh.
He's over in the region of Bangkok, Thailand. I don't know you're in Bangkok anymore, David. I think you said you're left Bangkok. You're not in Bangkok doing the teaching. I mean, I think you are, but obviously I don't know if your schools are in session right now. But it is pretty interesting, I that's sort of on my bucket list. Go to Bangkok, check it out. I just don't want to sing that song, One Night in Bangkok, and I don't want to do that. That would get stuck in my head, and I don't want to do that. I'm looking for something now that I suspect I should that I want to show you guys. So one second here. Let me look. While we're waiting to see if the sky's going to clear. Okay. Okay, that's true. Wow. Okay. I didn't even want to show Daryl because I don't think he actually saw what I'm about to show you guys. And some of you probably have. But, okay. So here we go. I'm going to open up my directory here and show you this amazing image. Okay, this image that you're about to see is not that. That's not the image. Is it this one? Yeah. So, what you're looking at here is the SkyTour LiveStream West door for the observatory, made by an artist who lives in Phoenix, and she decided to take an image of the Orion Nebula and build this image out of bottle caps. And the bottle caps haven't been painted. This is their natural color as they arrive. And she would bend them, cut them to square, and literally make them into what had to happen. And this took her an unbelievable amount of time. So I guess to say she's going to get free viewing for life out of the SkyTour LiveStream, even there on site, is an understatement. I mean, and of course, the person we're talking about is Tara D, who is in the chat right now. So you guys should definitely say some kind things to Tara, because if you look, this is really quite a beautiful door. Let me actually bring it down to size a little bit, make it easier to see. All right. Yeah.
I said earlier I don't see Bill Murray, but I do see the Baby Ruth bar.
Even here, there it is, right there, in the bay, right there. Yeah, and interestingly, okay, if we look, let me see if this makes it work too. Okay, if you look, all right, and we zoom in on just a little piece of it here. Hold on. Oh, that was the observatory initial design. Let me go back to, there we go. Okay, so if we look at this and we zoom in, okay, you can see the bottle caps. You can see how they're overlapping. Okay, right. This is Cherry Cola right down here. Okay, this is Bud Light. Okay, Tara did not drink all of these, just so you know. She has been collecting. She's an artist. She collects things. And I mean, look at that, huh? She went through a lot of bottle caps, and the process to just put them on there is not simple. Okay, she had to work around things like the lock on the door. Okay, she had to work around things like, okay, the hinge holding the door. Okay, so it goes around that. You'll notice that many of them overlap, right? And they all overlap. Otherwise, you wouldn't be able to get this built-up image. Now, the door panel behind it is a desert tan, and nowhere do you see the desert tan. Okay, there's only a slight hint of it right here, this little spot right here, but that's actually the other side of the hinge, and it's the same color as the door. So yeah, so there it is, and it's a stylized view of the Orion Nebula. But since Tara was here, I thought I would pass on that, she is the amazing artist that actually created the door of the SkyTour LiveStream West Observatory. So I think
well
that's
done,
cool.
Tara.
Yeah. So yeah, and Marianne Robb is here too, and Marianne, of course, and Tara are gonna install the door. I think next weekend, Marianne and Tara. I think you'll tell me. But this is what happens. See, this is the kind of people that are in Arizona. They step out. They step out of the crowd to help you. That's why I want to be there. That's why I want to move there, because the people that are there, they are incredible people. You know, you get stuck on the side of the road, someone stops and says, "Hey, you need help?" You know, because out there, you know, especially in the desert, if you get stuck in the desert, it could be a matter of life and death. You know, especially in the summer. So at the very least, people might stop and give you water. They might stop and give you a ride to town if something's really bad. And I've noticed that people tend to drop everything to be helpful out there. You know, here in Connecticut, not so much. They wait until you pass out and then they steal your wallet. You know, so I like it out there. I like the people out there. So anyway, and plus, it's open carry. You know, if I want to own a weapon, I can own a weapon, and you need one out there, not for against other people, but against critters. You know, creatures that could harm you. And I'm not a killer. I'm not a hunter. And anyone who knows me knows that I can't stand that. My mother was Native American, so when an animal dies, you know, you'll just find this science guy leaning over it and thanking its spirit for its contribution and so forth to the planet and making it a better place, kind of a thing. So, and that's something that it's hard to explain unless you've experienced it firsthand and you know how that feels. It just sounds like the ravings of some guy who's sort of like, he's ultra religious. No, I'm not. I'm not religious at all. Okay? There's a difference between that and spirit, right? And that's the kind of thing. And I've seen weird things, you know, and Daryl and I have talked about this actually before. There's weird things that happen on this planet to people and they can't explain them. And, you know, dealing with animals that have passed, for instance, that's one of them. I might have related a story to you guys. I had greyhound dogs. They were on the racetrack, and I didn't race them. I rescued them. They were just going to be euthanized, and I said, no. So I took Tycho and Kepler, astronomers' dogs, that's what I named them, and had them for 14 years. And when Tycho died, I was there with him, and I was holding his head. And I know the moment he passed away. I know the moment he died because his electrical energy shot right into my chest. And I was on a stool, okay, with my legs in the ground, a rolly stool in the veterinary office. Okay, I wasn't on the ground with him. And I was leaning over and holding his head. I was shot up into the air and back against the wall 2 feet away. In full view of everybody. This is documented. This isn't me, okay? And I have no idea what happened. I thought I heard a high-pitched whine in my head, and I felt like electricity, like I was electrocuted. And a year later, I had to do the same thing to my female. I had to have her put down too, unfortunately, because she had blood in her lungs, just like the male. And so, at the moment of her passing, I was kneeling on the floor now. I wasn't going to sit in a chair because I didn't know what to expect. And when she passed, her energy raced through me like a freaking bullet, and again flew me. I was on my knees. Now, in my knees, I was on my knees, and I was actually forced up into the air and backwards. And as I went to fall, I started to put my hand behind my head because I didn't want to hit the wall with the back of my head. And instead, I landed in something nice and soft, and arms came around me. It was the vet technician who said I was here last year. And that was really a very interesting thing. She was waiting for it to happen. And I didn't know if it would happen. I didn't expect it to happen. You know, I thought maybe that was something weird, whatever. So anyway, those types of things are, those are the unexplainables, you know, the things that we can't explain. Just like we can't explain where Tara got the talent to think, I'm going to make a door, I'm going to make an Orion Nebula, Messier 42, with the STLS logo. I'm going to make this door out of bottle caps. You know, where does that creativity come from, you know? I just think it's great. So, hey there, Vera Lucia Campos, how are you? Nice to see you here. So, that said, I will take one more shot here to see if we're gonna have a possibility of the sky opening up. And if we are, well then we'll do some more. I don't know that we will. And I'm sorry about my blinking webcam over there. I know exactly why it's happening, but I can't really do anything about it yet. I got to get another webcam. You know, it has this weird tendency to flicker. And for those of you that know, I mean, I just did a pilot on a major network for investigation. I was on an investigation team with 2 other people that are very, very high-end, wonderful people, friends. And we filmed for 13 days. And the interview that I had to do was with this webcam to do the interview with the executives at the studio. And my camera's going in and out, in and out, in and out, just like you see here. You know, I'm like, oh my gosh, you know. And I said, I hope you guys don't judge me for my webcam. And they laughed, and I got the job. So apparently, you know, and they called me. I didn't call them. That was when they found me, you know, because of what I do, I guess. Oh, but we'll see. Hopefully it'll go well, you know. All right, this is 20 seconds at 51,200 ISO. If we see pink, we're done for the night. And this is the moment of truth. We'll see how close you are, Daryl. Maybe you're right. It's worse.
There's an opening just south of you.
It'll only come over me as soon as I close up the dome and kill the stream.
No doubt.
Yeah. Well, anyway, folks, I want to thank you so much for coming out here and enjoying us for the evening. We tried to start off with a bang, and all we ended up with was a bust, and I apologize for that. But I don't know why. However, I do know that we will be back on the next clear night. That's a promise, and I'll make sure that we actually do have a real clear night. You know. But Daryl, I want to thank you for coming out and joining us. That's wonderful as usual. And I know that we'll have a lot of fun. And if any of you do want to talk about Photoshop, feel free. You know, I've been doing Photoshop photo analysis for probably, I'd say 10 years, maybe a little more, following the different iterations of Photoshop. It's only getting better. And you could subscribe to Photoshop for $10 a month, and that gives you the latest and greatest Photoshop. I think that's better than spending like $1,000 or more on a product that you install with DVDs. You know, and you learn. Hey, Don Walker, how are you? Yeah, I know. Thank you. He says, you know, too bad. Thank you for trying. Yeah, we did. But I like this image, and I think I'm going to make this sort of like a new image for SkyTour LiveStream. This is going to be really cool. All right.
I predict thousands of years from now, archaeologists in the future, maybe insect archaeologists, giant cockroaches, will unearth that, and it will be like us unearthing the old mosaic tiles of ancient Rome.
Did you hear that, Tara? Yeah, you heard that. Hey, Bobby. Oh my gosh. Yeah, that'd be funny. That's a very funny thought, Daryl. They'll say, and look at how they created their frescoes with these weird discs of metal. You know, the artisan had to spend so much time putting all these little fillets into the sides of these things, and then they crushed them flat, and it's quite amazing. Now, they all look about the same color to us because the color has long since worn away. We can only wonder what images adorned this fresco. Was it of religious significance? Was it of major importance to the culture? Probably both. You know, that's probably what they're gonna say.
And who was STLS?
Yeah. STLS. Was that one of their gods? It must have been one of their gods. Supreme Terran Light. Supreme Terran Light something. Serpent. They worship serpents. Supreme Terran Light Serpent. Oh my gosh. So, yes, see, you can see the snake. Look, you can see the tendrils all over the snake here. Look at it. You know? You can see that. There they are, right there. These tendrils all over this, the snake. So they're worshiping snakes. Our scholars think that this was a very advanced society for its time.
Put down the bong, dude.
That's the problem. I don't smoke any of that stuff. So, I mean, can you imagine if I did? Oh, man.
Yeah, I was sitting here thinking maybe it would be like the ancient Egyptians, you know, they didn't use vowels when they spelled out the words in hieratic or whatever it was called. You know, they just put down the consonants. So what kind of word might you make from STLS?
That's correct. So I wonder what they would say.
Oh well.
Well,
I'm gonna go. Thanks everybody. Had fun tonight.
Yeah, guys, thank you, Daryl.
Sure.
All right. Well, folks, thank you for sticking with us. We tried. We got off to a good start, and then the cloud said, "Oh no, you don't," and there they were right over us. It's almost like they put up their things and no, look, no photo, you know, and then they stopped us. But hey, you guys have a good night, and we will talk to you again. All right. So we'll see you the next clear night, and if that night is tomorrow night, I'll be right back. Okay, guys. So you guys have a good night. We'll see you later.
Night all.